Hello and good day to everyone. My name is Elsie Layu Martin and my course of study is Manufacturing Engineering Technology, majoring in Process and Technology. So today I will be presenting about my bachelor degree project, which is entitled The Study of New Green Concrete Based on Fired Unglazed Roof Tile West. And this project is under supervision of Professor Madya Dr. Zulkifli bin Muhammad Rosli. Firstly, I would like to talk about the presentation's outline, which include the introduction. In introduction, I will be talking about the objective of the project, the scope study, and the problem statement of the project. And second, I'll be talking about the literature review, where I have done research that is closely related to my project as a reference and as a guideline for me to conduct the research. So the third, we'll be talking about the methodology, where all the process to conduct the project is listed and explained in more details. So the fourth one is the most important part of the project, where the result and analysis is obtained from the methodology that had been conducted in the project. And lastly, we'll be talking about the conclusion, which include the project potentials and recommendation for further study of this project. So the idea of this study, where producing new green concrete that is based on unglazed roof tile, is when roof tile manufacturers are having difficulties to manage the defective roof tiles and accumulated from time to time, which is lead to waste. So to rework the defective roof tiles may cost them financially and affect the quality of the roof tile itself. Basically, the ingredient of concrete is based on four main ingredients, which is cement, fine aggregate, coarse aggregate, and water. So URT, or the unglazed roof tile waste, will replace the fine aggregate by proportions. So the first objective of this project is to develop mixed design formulation by using Microsoft Excel as a tool to calculate the proportion of the URT to substitute fine aggregate, which is sand. So the second will be to change the physical properties of the unglazed roof tile waste into fine aggregate by few processes, which is first will be crushing and second will be milling process, and all of this procedure is based on British standard. So the third objective of the project is by investigating the mechanical behavior of produced green concrete at 28 days that is based on unglazed roof tile waste, and then to compare with conventional concrete. Alright, so let's move on to the next topic of this presentation. So I'll be discussing about the literature review that is based on previous studies. So here I have listed four type of journal that are similar to my project, but using the different material, but same testing method with various outcome. So basically, I'm gonna just summarize everything, where the outcome of each of the study is mostly talking about the development of compressive strength at 28 days. So basically, the development of compressive strength decrease when they reach at 28 days, but having a good compressive strength at the early age, which is 7 and 14 days. However, for some research also saying that there's a reduction in compression strength with the increasing percentage of the recycled aggregate. Alright, so for my research study, I have created this four process for more systematic process to conduct the experiment or the research study. So firstly, the first thing I will be doing is to fulfill the objective one by calculating the concrete mix design, and second process will be focusing on the material preparations, which is sand, gravel, URTW, and water. And the third objective is when the concrete will be mixed together with the URT, and the conventional concrete also will be made as comparisons at the end of the experiment. So basically this is the process, and next I will be talking about the methodology in more details, where all the data will be analyzed from this methodology. To produce new green concrete that is based on roof tile waste, calculation is needed to know the proportions of each ingredient that is included in the concrete. So basically here is the form that is prepared by the British standard to fill in to calculate each of the ingredient that is needed for the concrete or for the mix. And actually the process of mixing design is about determining the right proportions of cement, the fine aggregate, coarse aggregate and water. In addition to produce an economical concrete mix, by using admixture in the concrete is also considered, but however, I have not used admixture in my concrete. Since my first objective of this research study is focused on the calculation of mixed design, so I have come up with this or developed these formulations to calculate each of the proportions ingredient that is included in concrete. So this formulation is carefully developed based on the British standard or the form that I have been talking about in previous discussions. From the formulation that I have already developed, it will give the quantity of the cement, fine aggregate, coarse aggregate and water together with the water cement ratio. Overall, it also will give the finalize the ratio for the mixing. From the ratio and the quantity of the ingredient needed, proportions of URT to substitute the sand also will be calculated. As for my research study, the proportions to substitute sand is starting with 40%, 50% and 60% of URT to replace sand. Next, I'll be talking about the material and apparatus preparations for the process of this research study. The first step is how the URTs look like, and second will be fine aggregate, and here the fine aggregate is sand, river sand, and third will be coarse aggregate, and the cement used for this research study is 32.5 hours of cement grade. Basically, this is how the raw material of Unglazed fired roof tile waste look like before it's been crushed into a fine aggregate. Alright, so here I'll be talking about the methodology of the research study. Since my second objective is talking about to change the physical properties of URTW into fine aggregate, so in the methodology I have conducted the crushing using 4 different type of machines, where the first one will be crushing the machines by using a machine crusher in Polytechnic Melaka, and third will be cassava crusher and roselle cutting machines at the stage 2. And the reason using 2 different type of machines in the second stage is because last semester or the previous semester we have been using cassava crusher as our crusher to crush the RTW into 3 mm size of aggregate. However, for this semester the cassava crusher is not available, so we find other alternative to use roselle cutting machines to crush the RTW into the smallest aggregate, but the minimum size of aggregate that can be crushed, that is produced by roselle cutting machines, is only 5 mm. So from there will be a different parameter for 3 mm and 5 mm for the stage 3, where the planetary ball milling machines will be finalized the crushing process and will produce the RTW, which is exactly imitate the sand physical properties. Since I have mentioned earlier that in stage 2 I have using 2 different type of machines crusher, which is cassava and roselle, where the size of aggregate will be different. When the size of aggregate will be different, the planetary ball milling machine parameter will be different. So for 3 mm, The duration to grind the URTW will take 20 minutes, and for roselle cutting machines that crushes URT to 5 mm will be taking 25 minutes durations to crush or to grind the URTW um, to imitate the size of the sand. After the process of milling the URTW using planetary ball milling machines, the next process will be grading process. This grading process is by sieving the material using a siever. And the first picture is where the material is filled at the top of the stack of the sieve, and then it will be covered and put on the vibrating sieve shaker. And the sieve shaker will be run for 10 minutes, and after 10 minutes the sieve will be opened up, and each of the stack will have a return particle at each compartment. The return particle at each compartment will be weighed to be recorded and to be analyzed. The reason of doing the grading process earlier is to make sure that the size of sand and URTW is within the range that is required in British standard. So this is the analysis that is obtained from the process earlier. And the process of this grading of fine aggregate also in accordance with British standard as stated below the graph of sand and URT sieve analysis. So by judging the graph, both of the aggregate for fine aggregate is within the range. Next, same as the previous process, coarse aggregate here is the gravel that is mixed with the concrete. So same process as before, the coarse aggregate also need to be sieved and to be analyzed to make sure that the size of the aggregate is within the range. The grading of coarse aggregate also from the British standard that is stated below the graph. After the grading process and sieve analysis have been made to ensure the size of the aggregate is within the range, the next process will be mixing all the ingredients together. So for the first batch of mixing is conventional mix, where there is no URT or there is no recycled aggregate is included. All the procedure of mixing to make a concrete cube is based on the British standard, which is 12390, part 3 in the year of 2000. Generally, this is the preparing process of the concrete, where all the concrete will be mixed together except for water in a dry state. So during the mixing, the water will be added in gradually, little by little. When the fresh concrete is already well mixed, it will be placed into a slump cone for slump test. Slump test is the most important procedure need to be done during the mixing, because it is to measure the workability of the fresh concrete before it's hardened. Workability of the fresh concrete here means how well or how easy the fresh concrete is being handled. So the next process is placing the fresh concrete into a steel mold. During casting or placing the fresh concrete into the steel mold, tamping the fresh concrete is also an important step to do to make sure that the concrete is carefully compact and to remove all the air trapped in the concrete. Removing the air in the concrete is important to avoid large porosity occur during the concrete is already hardened. So move on to the next process is by labeling the concrete that already been cast and let it harden for at least 24 hours to 48 hours. Approximately after 24 to 48 hours, when the concrete is hard or easy enough to be handled, it will be placed in a tank full with water for curing process. The curing of concrete actually to regulate the rate and the level of moisture loss from the concrete during cement hydrations. As I mentioned earlier, during the mixing process, there will be a test conducted during the process, which is slump test. Slump test is conducted to measure the workability of the fresh concrete. So slump test is basically measuring the drop of the slump from the original height within 0 to 3 seconds. From the slump test, the result will be obtained and the workability of fresh concrete will be analyzed into a graph. So before that, red dotted line at the bottom and below is the maximum and the minimum of the slump value for the slump to drop. From the graph here, we can see that the control mix with 0% of URTW and URTW 50% proportions is within the range. However, for concrete URTW with the proportions of 40% and 60% is out of range. Since slump test is to measure the workability of fresh concrete, from the analysis, URTW 40% concrete and URTW 60% concrete having the lowest or out of range slump value. This is means that the workability of both concrete are very low and very hard to handle. Even though the result for slump test value of URT 40% and 60% is out of range, the mixing is not being modified in terms of its water ratio because to maintain the ratio for the compositions, because it will be comparable in terms of its strength at the end of the experiment. After 7, 14 and 28 days, the concrete cube will be taken out from the tank for the next process. The next process will be measuring the water absorptions of the concrete cube. Basically, measuring the water absorptions of the concrete is by weighing the weight of the concrete cube before and after immersing the concrete cube in water for 7, 14 or 28 days. Based on the analysis data of water absorptions of the concrete, maybe the control mix and the green concrete, all of the data are within the range, which is less than 3% of water absorptions of concrete. However, URTW 50% showing that it has the highest value of water absorptions compared to the rest of the other concrete, but still within the range. Last but not least, for studying the new green concrete that is based on unglazed roof tile waste as a fine aggregate is by conducting a compressive strength test on the concrete cube at 7, 14 and 28 days. Compression strength testing was conducted on 2 different types of machines. The first machine is a hydraulic press compression machine, which is located at Poli Melaka, and the second type of machine is a class 1 motorized hydraulic compression machine, which is located as CAS Consultants Sdn Bhd in Cheng. The reason of using 2 different type of machine to test the concrete cube is that there are circumstances that couldn't be avoided, but luckily all the 28 days concrete is tested only using 1 type of machines. So mostly all the data and analysis for the concrete is only focuses on the 28 days, because mostly on the British standard, all the procedure of conducting compression testing is focuses on the 28 days. After conducting the compression strength on the concrete cube, the data will be collected and analyzed. However, for this research study, we chose M25 concrete grade as our benchmark to produce the new green concrete. So M25 means M stand for mix, 25 stand for the characteristic strength, that need to be achieved by the concrete at the 28 days. So 25 Newton millimeter square is the minimum for the concrete need to be achieved at 28 days. Based on the data analysis that obtained from the compressive strength testing, the red dotted line in the graph showing the minimum compressive strength that need to be achieved at 28 days by the concrete cube. The green dotted line showing the target mean strength for each of the concrete cube. By referring to the data analysis, all of the compressive strength of the concrete is past the minimum strength at 28 days. And also, we can see that the development of compressive strength is increasing with the increased percentage of replacement for URTW. Since all the variations of concrete pass the minimum characteristic strength of concrete at 28 days, but not all of the variations of concrete is within the range during slump test result to see the workability of fresh concrete. Conclusion for this research study: by developing the formulations of concrete mix design using Microsoft Excel, the proportions of every quantity for the ingredient are easily to be determined without calculating it manually to avoid miscalculations. Furthermore, the formulation was also carefully developed based on BRE method to satisfy the required compressive strength and value of water cement ratio and any other requirement needed for the concrete mix. To replace the sand with recycled aggregate, which is unglazed roof tile waste, the roof tile waste from big piece was crushed by complying to the British standard, of course, and the physical properties of the URTW must imitate the size of the sand, so sieve and grading process was conducted to ensure that the size of a recycled aggregate is exactly or imitate the size of the sand. For further study on improvement, the material preparation need to be done according to the procedure in British standard requirements, because to avoid a false value, especially during slump test, each of the material preparation need to be done really carefully. So the 50% replacing the recycled aggregate in the concrete mix is the best proportion to be used and could be considered to be used in constructions in the future. I think that is to summarize my presentations about the study of new green concrete based on unglazed roof tile waste. Thank you.